Hello everyone, this is our video for our Can You Do number 3. Now even though this is meant for you guys, the Can You Do's are always meant for you guys to do on your own. I thought that this first problem on the one for displaying quantitative data would be a good one to clear up some things about stem and leaf plots. So number 1 says, a recent study by the Environmental Protection Agency measured the gas mileage in miles per gallon for 50 models of cars. The results are below. So all of these are the miles per gallon for the 50 cars that the EPA looked at. They want us to make a stem plot of this data. So hopefully you've already watched the stem plot video and you are recognizing that these values are much different than the values that we looked at in our stem plot lesson. Most specifically, these are decimals instead of whole numbers. So when we make our stem plot this time, this is going to be the first one where our stem is 2 digits long. Because when you make a stem and leaf plot, the leaves can only be 1 digit. For instance, if we had the number 115, you could not do 1/15. This is not equal to 115. This is equal to 11 and then 15. So we can only have our leaves be 1 digit, which means in this case, we need to make our stem the whole number, which is going to be 2 decimals long. The other thing, I think I already said this, I'm sorry, it's really late at night and we just did PTCs, but the difference here is not only is it a decimal, but it is the first one where your stem is 2 digits. So when we make a stem and leaf plot, the first thing that I do is identify the minimum and the maximum value. So you go through the table, pause, go through the table, find the minimum value and the maximum value. So your minimum is 31.8 and your maximum is 42.1. So we're going to use this to set up our stems. So I'm going to start my stems at 31 and I'm going to go by ones all the way to 42. I'm verifying that I have sound. Give me just 1 second. Okay, I had sound. So now that we have our stems listed out, we want to draw that vertical line that separates our stems from our leaves, and we want that to be as straight as we can get it. It doesn't need to be perfect, but it needs to be pretty straight. And at this point, I'm going to start placing the leaves on my stem plot. So I'm going to go by columns. I'm going to start with 36.3. So what we do is we go to the 36 stem, we write a 3. Then we go to the 41.0, so go to the 41, write a 0. 36.7, we go back up to the 36, write a 7. 36.9 and 42.1, we go to the 42 and we write a 1. And then I'm going to put a little X at the bottom of that column to say that I graphed that. Now I'm going to go to the next one, 32.7, so go to the 32 stem and write 7 as your leaf. 37.3, 33.6, 41.2, 37.5. So that one is done. And we keep going. I'm going to do this one last one. 40.5, 36.5, 34.2, 37.6, 40.0. So maybe some of you guys are asking yourselves at this point, hey, don't our leaves need to be in order from least to greatest? And the answer is yes. But I like to make a stem and leaf with the data values first if it's not ordered. And then I use this stem and leaf to order the numbers to the right of the line, because I don't want to have to put 50 numbers in order from least to greatest. I don't want to rewrite these numbers in order from least to greatest. So I think that it's easier to just take the data as it is, plot it in a stem and leaf plot, and then once I have this, make another stem and leaf plot and order the leaves. So what I want you guys to do at this point is pause, and I want you to go through and finish the next 6 columns. You are going through and finishing the next, actually it's 7 columns. So really pause. Okay, welcome back. Hopefully you really paused. So this is my, that's not a good one. Sorry, let me get a different one. This is my stem and leaf without ordering them. So I have not gone through and reordered the value of the leaves. This is also a little bit messier. I just wrote down my leaves because I knew I was going to make a second stem plot. And now on this stem plot, I want you to write your leaves in the right order. So pause the video, make another stem plot, and then we'll check back on these. Okay, hopefully you really paused. So on mine, it looks a little bit different because I drew the bars in. But on this stem and leaf plot, I tried really hard to make my numbers line up vertically. And if you go through, you can see that all of my leaves are in order from least to greatest. Now, the awesome thing about a stem and leaf plot is that not only does it give you a good look at the shape of the data, but it also lets you see the data values. So in this case, yours hopefully doesn't have the bars drawn on it right now. Those bars are drawn there for the next question. But if you look at the shape of this data, there's nothing really too unusual, nothing really sticking out. You would call the shape of this data symmetric, meaning the left-hand side looks similar to the right-hand side. There's no gaps in the data, there's no skew. So this is one of the advantages to a stem plot, is that you can see the shape of the data and you can see the values of the data. The one other thing that I like about a stem plot is that you can see the values in the data set. So the one other question that was asked a lot today in class was, how do you choose the key? So first, I have my graph labeled. This is the MPG, the miles per gallon. When you choose the key word there is you choose. You get to decide what value you use from the table to write your key. I could literally close my eyes are closed, point to a value on the graph and use that as my key. So I would write 36, vertical line, 0, and then say that is equal to 36.0. So that's exactly what I did in class today here. I just closed my eyes and pointed to a value, and I landed on 34 vertical line 2. I now know that that's 30.4.2, not 342. So you absolutely need a key to be able to determine how you read the stem and leaf plot, and you choose the key. It can be any number from your data set. So we just need to make sure that we tell whoever is reading our graph that this means 34.2 and not 342, or not 342,000, or not 34,200,000. There's so many different things that this could represent that you have to write a key. So then the next part of this problem wants us to use our calculator to construct a histogram. So you're going to want to go through and enter in all of these data values. I would go using the columns again, and once I get to the bottom, I would just draw a straight line through it so I know which ones I've entered. By the time your list is done, you should have 50 numbers in your list. So you should pause now. Well, you should go into your stat, hit 1 for edit, and then choose a list to enter these values into. If you need to clear out a list, you highlight the list number, hit clear, and enter. Never hit delete. Okay, now pause and enter in those values. Okay, so welcome back. Mine are in list 5. I'm going to verify that I have the right amount, so I'm going to arrow up. Notice here at the bottom of my list it says 51. That means that I do have 50 observations. So now what I am supposed to do is graph this list. So what I'm going to do is I'm going to go to, from whatever screen you're on, I'm going to hit blue button, Y equals button. I'm going to make sure only one of my plots is on. So my plot 1 is on, so I'm going to go into that. I'm going to arrow down and make sure that I choose the histogram. I'm going to make sure that my list is the right list. If you need a refresher, that's your blue button and the number of the list that you want. And then from here, you hit graph. Okay, I don't see my graph, so what should I hit? If you watch the lesson on histograms, you should know what I need to press now. So hopefully you're saying zoom, zoom stat, so zoom in 9. And now I can see my graph, and the question is, do I get the same graph as I got on the stem plot? So I'm going to go back to my stem plot, and now hopefully you can see why I had those bars drawn. If I compare these two graphs, they look similar. Like I have a really tall bar here and I have a really tall bar here. But on my stem and leaf, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bins or 12 bars. And on my calculator, I only have 1, 2, 3, 4, 5, 6, 7, 8 bars. So this says, how can I make this calculator look like this stem and leaf or stem plot? So the key is you want to go to your window and you want to adjust your window. So on your stem and leaf plot, your minimum value is 31. So I'm going to change this X min to 31. My maximum X value was 42. So I'm going to change that to 42. And then each time I increased by 1. So 31, 32, 33. So I'm going to change my X scale to 1. If I hit graph now, I am going to get a histogram that looks like my stem and leaf. And what's really cool is the number of leaves in the bars I have drawn will be the same number of observations on your calculator. So to find that, I go to trace. And if you look down here on the bottom, this means that in bin 31, I should have 1 observation, and I do. In bin 32, I should have 3 observations. In bin 33, I have 1, then 3, then 4, and then at my 36 bin, I should have 12 observations, and if you count those leaves, there is 12. So in order to make these look the same, we went and we adjusted our window. We adjusted the window so that it matched the stem plot. When I do a histogram using my calculator, I usually always write down the window that I used, mostly for my own reference, but also because I think that that's really good practice. So the one last thing that I want to talk about on this can you do before I let you finish the backside on your own is the advantage to a stem and leaf compared to a histogram. So a stem plot is going to give you much more information. This gives you more info because you can see the actual data values. So not only does it look, or can it look the same as a histogram, but it also gives you the exact data values. Whereas with a histogram, you get less info because it doesn't tell you the data values. It just tells you the frequency in each bin. So if this would have been given to us in a histogram first, the only thing that we would know is that 12 cars got gas mileage between 36 and 37. Or 8 cars got gas mileage between 37 and 38. So a stem plot gives you more info because you can see the actual data values. A histogram gives you less info because it only shows you the frequency in each bin. And I would definitely write those down because you do see this later on your can you do's and quizzes. Okay, so at this point, you have everything that you need to finish this. The back side is 3 problems. It is a dot plot and 2 multiple choice. I will make a solutions video for this, but this is your first task for today, is to finish your can you do. Next up will be medians, and then quartiles, and then finally outliers.